Thank you. Very excited to speak with you today, and it's quite fortuitous timing because just this weekend, as you probably saw, there was a large swath of the internet that's went down. And if you're on the west coast of the US, it happened during working hours. And coincidentally, a coworker of mine, completely innocently, said on Slack, I really have work to do, but service X is down, so I'm just going to go with service Y instead. And now, anybody can be hit with a DDoS, but the big thing to really take away here is that you want to do everything you can, especially as a B2B business, to make sure that you're always available for your customers. So what I'm going to be talking about is how we did that at Algolia. Algolia is a hosted search API, and we focus on developer and user experiences. We do this by looking at replies in milliseconds. Our goal is to get a response within 50 milliseconds. Our motto is search at the speed of thought. From anywhere, you shouldn't suffer slow speeds just because you're in Sydney versus San Francisco. No matter where your customers are, they need the best experience possible. And we do this with intuitive relevance. There's a lot of great open source search solutions out there, but you can really wrestle with them, not really understand the algorithm on the business side, or put a lot of developer resources into it on the tech side. At Algolia, we want everyone from business to tech and in between to understand how the search works. So Algolia today, we power the search for over 2,000 different companies in over 100 countries. That's 30 billion write operations each month and over 15 billion queries over the same time period. We're in 15 different regions, 47 different data centers, and we power the search that powers companies like these, but also large companies like Twitch, all the way down to small e-commerce shops. And if Twitch or these e-commerce startups or anyone in between is going to trust us, we have to be available for them and then in turn available for their customers. So what we're going to be talking about is the behind the scenes, Algolia's Fury Road to building a worldwide API. And we'll go all the way back to March of 2013. This will be a trend that you see over and over. We thought about high availability. We designed it from the very beginning, but we didn't implement it just yet. We set the wheels in motion, but we wanted to learn how people were interacting with the engine and how the engine was interacting with the people. We started out with a single machine in 2 different regions, and we were able to get up and running with our first customer before we had even officially launched. In June of 2013 is when we really started with that implementation of the high availability. We rolled out 3 different machines with the consensus on write, which essentially means you send us some data to index in the search engine, and we're going to make sure that it's on every single machine so that if any of those go down, we're still going to be able to provide the data to your end users. All of this was baked into our API clients. We talked about developer experience. We don't want developers to even think about all the hard work we put into high availability. We just want them to know that at the end of the day, it's going to work. August of 2013, we saw the official launch of the service. We were still in those 2 locations, but we knew we wanted to be global from the very beginning. We were at the same provider, but we sort of backdoored our way into a cheap multi-availability zone by having different network equipment and power units so that we could more ensure that our machines were going to stay up. And we had 10 API clients across different languages and frameworks. We did all of this manually, all of this API client creation. We could have gone through automatic code creation, but it was so important to us to be able to know that the technology to keep the system up was going to work. Deployment is a big risk. As any developer, it's an opportunity to introduce bugs into the system. And we learned that ourselves. We were very agile. We had over 6,000 unit tests, over 200 non-regression tests. but we had no instant rollback. And a bug was introduced into the system, and we had 8 minutes of indexing downtime. Thankfully, search was still up, but it wasn't fun to go to our customers and say that you may have to re-index your data because we had this downtime. So what we learned there is we always now start with test clusters. We have these community projects like Hacker News Search, where if it goes down, it's not great, but it's not as bad as a customer in production. And importantly, these test clusters are getting real traffic. That traffic is going to find bugs that you won't be able to find with your tests. And of course, now we have instant rollback as well. As we grew and became more and more complex, running all of this through shell scripts just became too unwieldy. So we moved to automation via Chef, but stuff happens, and a typo nearly broke our product. So now, we roll out machine by machine slowly, and we always have the stable and then the production taking over bit by bit. DNS, this is what we saw over the weekend, and it can be a point of failure in the architecture. We were getting feedback from customers in Asia that there was infinite slowness. Our searches were not taking 50 milliseconds, sometimes they were taking over a second. And we narrowed this down to the .eo top-level domain. After speaking with a lot of people in the CDN space, we discovered and realized that the .NET TLD was the most reliable, and so we moved over to that. That led to our largest downtime so far, what we call Black Thursday. We have a blog post where we go into detail on the postmortem, but it was a very valuable lesson for us and just how important reliability for DNS was. February 2015 was really big for us in terms of our high availability. We launched our worldwide synchronized infrastructure. We went from 4 different regions to 12. This meant that we could replicate that data and have low latency no matter where you are in the world. We call this the distributed search network. Before, if your data was hosted in France, but you had customers in US West, in Sydney, and Asia, then they had to make that round trip, and that added just a ton of latency. But now, through our API clients, the customers are going to search whatever location of the data you've chosen is closest to them. This really helped with high availability across different regions, but we want to beef up availability within a single region. Before, we had our clusters in one data center. This was a single point of failure, because if that data center went down, the electricity gave out, anything happened, that search is going to go offline. So we spread it across 2 different data clusters, 24 miles, only added a millisecond latency, 3 different machines, and completely different autonomous systems, so that we added even more reliability there. Next, taking that lesson of the DNS, we actually introduced several DNS providers. This has saved us so many times. When our DNS provider maybe has a DDoS attack against it, we can just fall back to our secondary DNS. So we're not reliant on just one provider. And it's something that's been huge for us. And again, built directly into the clients. You want high availability, but you don't want to force your customers, the developers, to work to get it. You want to provide it all to them. Talked a little bit earlier about how we moved to 2 independent clusters. A little bit about how Algolia works is we have those 3 machines, and we need at least 2 of them to be up to make sure that we're receiving that data and that all the data is consistent across the machines. Machines go down, it happens even buying the top-of-the-line machines. But if we had those 2 providers, and we had 2 machines in one provider and 1 in another, and 2 machines went down, we lost indexing. So we've now moved to 3 different providers across all of our clusters. So the chance of 3 independent providers going down, very, very small. So again, step by step, we designed high availability from the beginning, we increased it, and we increased it. Most recently, we moved to some finer grain monitoring. Before, we were using server density, where we could have monitoring at the minute level, which is nice, but we've since moved on to wayfront, and we can now see it at a second level, and we're monitoring 500 metrics per server, so that we're able to see if anything goes wrong, not at the minute level, but really drill in deeply and figure out exactly what's going on. It's incredibly important to be able to know and be able to figure that out. Otherwise, you're going to be sleuthing for a long time before you're able to get down to the root cause. In the end, building a high availability architecture takes time. You really have to think about it from the very beginning. But at the same time, don't spend your time over engineering. You don't know how your customers are going to interact with your products. And you really want to focus on execution. Being able to do this has given us a reputation with our customers and with potential customers that has allowed us to bring in large enterprise customers that wouldn't have looked at us otherwise. In other situations, we've gone into meetings with dev teams who have been very skeptical on the outset, and they learned about this, and we really were able to win them over. So in the end, building high availability architecture, especially in the B2B space, is a ton of work. But if you do it right, and if you really focus on it from the very beginning, you're able to build this reputation for your customers. So I'll be around all day. We have a full blog post that really goes in depth into what we did for high availability. So find me afterwards and let's chat about building high availability B2B businesses. Thank you.